Hello everyone, welcome to Maths Expressions. My name is Alexander Maduka, and in today's video we'll be looking at a new topic, which is unified formula for area of a segment, part 1. Unified? Yes, because in today's video we'll be discussing something very interesting, which I bet you have never seen a kind of it before. But you don't have to worry about the new topic you're seeing. By the end of this video, you will have a full understanding of what this topic is all about. We'll break everything in details in this video. So stay with me in this video as we discuss this topic together. All right, let's get started. Okay. It says, below diagram is a circle of radius 4 centimeter divided into a minor segment ABC and a major segment ADC. This is the diagram is talking about, this diagram here. So as you can see, it's a circle that is divided into a minor segment ABC. This one here is referring to this minor segment, and the major segment ADC. This one here is referring to this major segment, and with some number and with numbers labeled at some parts of this diagram here. This number you're seeing here, this one here, is the length of arc of this minor segment. While this number you're seeing here, this one here, is the length of arc of this major segment. This number you're seeing here, this 120 degree you're seeing here, is the angle of this minor segment ABC, while this 60 degree you're seeing here is the angle of this major segment ADC. Okay, and this line you're seeing here is the radius of this circle, which is 4 centimeter. Okay, now we have some questions to answer. We have some questions to answer from this diagram above here. This diagram here, we have some questions to answer, and the question says, from the above diagram, question A says, find the area of segment ABC. Find the area of segment ABC, which is this minor segment. And question B says, find the area of segment ADC. Area of segment ADC, which is this major segment. And question C says, add the area of both segments to get the area of the circle. Add the area of these two segments to get the area of this circle, because this circle is divided into two to get this. This circle is divided to get this minor segment and this major segment. So adding the area of these two segments will give you the area of this circle. Okay, now let's solve this problem together. Now let's solve problem question 1. Okay, the question 1, area of segment ABC. Now first we'll list the parameters, then we'll now solve for the area of this segment, area of this minor segment to be precise. Okay, length of arc ABC, let's call it L, is equals to 8.38 centimeter. This length of arc, as I said earlier. Then length of chord AC, let's call it D, is equals to 6.93 centimeter. This length of chord here, AC, this line here, is the length of chord of this minor segment. Then angle of segment ABC, let's call it theta, is equals to 120 degree. Angle of this segment ABC is 120 degree. Now surface area of segment ABC, S. Okay, now solving for calculating the area of this minor segment, you might think that we'll use a method which you are used to, that is finding area of a sector. Maybe somehow we'll first try and find the area of a sector, then after finding the area of a sector, we will now minus the area of this inner triangle and call the remaining part area of the segment. No, we're not going to do any of that in this video. Instead, I will introduce a new formula to you that we will use and solve this problem that we use and calculate the area of this minor segment, which works like magic. Okay, and this is what the formula looks like. area of segment ABC. Let's call the area of segment ABC SA, which is the area of this minor segment. SA is equals to D times open bracket L plus D cos theta all over 4 times sine theta close bracket. This formula you're seeing here is called Fredoms formula. And as you can see, our topic says unified formula for area of a segment. This is the unified formula because this formula you're seeing here solves for area of a minor segment and also solves for area of a major segment. You don't need to change anything, whether it's a minor segment or a major segment. Just plug in these values you are seeing here. Then this formula we calculate the area of the segment for you. That's why it's called unified formula for area of a segment, which that is Fredom's formula. Okay, now let's use this formula so that you will see how the formula works in action. Now SA is equals to 6.93 times open bracket 8.38 plus 6.93 times cos 120 all over 4 times sine 120. So if you plug in these values into this formula, this is what your equation will look like. Now if you do this equation, we will get 6.93 times the numerator part will give you 4.915 all over the denominator part will give you 3.464. So if you use your calculator, we will get SA is equals to 9.83 centimeter square, which is the area of the minor segment. As you can see, in a very few steps, we have arrived at the area of this minor segment. That is the magic of this formula here. It's a very interesting formula. Now, let's solve question B. Now, question B, from that question B, area of segment ADC. Now, let's list those values before we now use the formula. So, length of arc ADC, let's call it L, is equals to 16.75 centimeter. Length of chord AC is equal, let's call it D, is equals to 6.93 centimeter. They are the same value because it's the same line that divided that circle into that major segment and the minor segment. So that length of chord has the same value. It doesn't matter whether it's the major segment or the minor segment. Okay, and that is it for that one. So angle of segment ADC, let's call it theta, is equals to 60 degree as I showed you earlier in this diagram. In this diagram here, these three values, this one, and this one, that's the values we are using for the major segment inside Fredom's formula. Okay, that's all we need. That's all the parameters we need to calculate the area of that major segment with Fredom's formula. Now let's call the area of this major segment SB. SB is equals to D times L plus D cos theta all over 4 sine theta close bracket. As you can see, nothing changed from this formula. The same formula which we use to calculate the area of the minor segment is exactly the same formula that we want to use to calculate area of this major segment, and that is Fredom's formula for you. So if you plug in these values here, our equation will look like this. SB is equals to 6.93 times open bracket 16.75 plus 6.93 times cos 60 all over 4 times sine 60. So if you do the math, we will have 6.93 times the numerator part of this equation will give you 20.215 if you use a calculator, and the denominator part will give you 3.464. So SB is equals to 40.44 centimeter square, which is the area of the major segment. Okay, now let's solve question C. As you can see, with this formula which we use here, we have arrived at area of the major segment, with few steps also, just as it happened when we were calculating the area of the minor segment. Now let's solve the question C. Now area of the circle. Let the circle's area be S naught. This implies S naught is equals to SA plus SB. That is area of the major segment plus area of the minor segment, plus the area of the major segment as directed by the question. So now the area of this minor segment is 9.83 plus area of this major segment, which is 40.44. So the area of this circle, which is S naught, is equals to 50.27 centimeter square. Now we will not just look at, now we will check to know how true is this. So what we're going to do now is we're going to solve for the area of the circle directly without calculating. We're going to solve for the area of the circle directly. So now area of a circle, A is equals to pi r square. This is the formula for calculating area of a circle. Now from the diagram, we know that L is equal, the radius of the circle, which is R, is equals to 4 centimeter. This implies area of a circle is equals to pi times 4 square, which is equals to pi times 16. At the end, we finally get area of a circle, A, is equals to 50.27 centimeter square. As you can see, we calculated the area of the circle in different ways, and at the end of it all, we got the same answer at each cases. So we got the same answer. The same answer we got from the first way which you solve for the area of the circle. The same answer we got from the second way which you solved for the area of the circle. So, and that is it for this video. In this video, I've shown you a very interesting formula, which is Fredonm's formula, a first formula of its kind to calculate the area of a major segment and the area of a minor segment without changing anything. Because in other ways of calculating area of a segment of a circle, it's totally different thing, because the way we calculate area of a minor segment and the way we calculate area of a major segment is totally different thing with the other method. But in this method, we used the same formula and we got the correct answer for the area of each segment in this diagram, and that is Fredonm's formula for you. So that is it for this video. If you find, like as I promised you before when we were starting in this video, that you're going to learn something interesting today, and which I have shown it to you, that is Fredonm's formula, a unified formula for finding area, for calculating area of a segment of a circle. It doesn't matter whether it is a major segment or a minor segment. So if you find this video helpful, hit the like button and share this video so that it might get on that person that needs this video, another fellow maths lover like you. And tell us what you think in the comment section. If you have seen a formula like this before, or if you have any other way, or if you have seen any other way in which you can use the same formula to calculate area of the major segment and area of the minor segment with one formula, I will be glad to discuss that with you in the comment section. So put your thought in the comment section and subscribe to this channel. In this channel, we will upload interesting topics, new topics, and we usually introduce new formulas, as you can see in this video, in this channel. So subscribe to this channel so that you will always get notified whenever we upload video in this channel. And thank you very much for watching this video. I would like to see you in my next video.